Hello everyone. Today we are going to study transistors, that is BJT, Bipolar Junction Transistor. In this we are going to study NPN and PNP Transistor, its symbol and construction of the transistors. So let us start. The bipolar transistor basic construction consists of two PN junction producing three connecting terminals, with each terminal being given a name to identify it from other two. And the three terminals are known as emitter, base and collector. So here we are going to study in this NPN transistor, its construction and working. From the figure itself, it is quite clear. We can see this is N-type semiconductor we have used. Here also we have used a N-type semiconductor, and in between the two N-type, a P-type is sandwiched. And this P is lightly doped, whereas this emitter is heavily doped. This part you can observe it is quite bigger as compared to emitter, and the base is very small as compared to the emitter and the collector. See, this is the emitter, this is base and this is collector. These are the three terminals E, B, C. Okay. And the symbol for this NPN, you can see this emitter have a arrow, and this arrow is towards this round, towards this circle. In NPN transistor, it is towards the circle, and in PNP transistor it is towards the base, that we are going to see in further video. So here we can observe, and which is quite clear, the construction of this NPN transistor. NPN transistor is consisting of 2N and 1P. Okay. And this is the most commonly used transistor. Here we have two N-type semiconductor materials on both the side of the P. Okay, and this form this PN junction. This way PN, this is the PN junction, first PN junction, and again P and N. So here another junction forms. So the two junctions formed in this, isn't it? And this transistor is current operated device, and large current flows from this collector. So that we are going to study in a further slide. Okay, so I hope it is quite clear. This is the construction of NPN transistor consisting of 2N and 1P. This P is sandwiched between the two, that is the emitter and collector, and it is observed that this base is smaller as compared to the emitter and collector, and it is lightly doped. Okay, so B, this is base, this is in the center, and the two lids, that is this is collector and this is emitter. So emitter have an arrow, and in NPN transistor it is towards this circle or towards this E terminal. So let us proceed. Here, now we'll see how it works. This is NPN transistor, emitter, base, collector. N is negative, connected to the negative terminal, whereas this N, that is collector, is connected to the positive terminal. This IB, that is the base current. This is IC, that is the collector current, and this is the IE, that is the emitter current. In this, actually, IC flows freely through this device between the collector and the emitter when the transistor is switched fully on. However, this only happens when a small biasing current IB is flowing into the base. Okay. At the same time, allowing the base to act as a sort of current control input. And what I said now, that we are going to get clear in this figure, and will try to understand how the electrons and holes moves through this. We have considered some of the electrons in number 1, 2, 3, 4, 5, 6 and 7, like this. Okay. So by understanding these numbers and the flow of electrons, we are going to understand the working of NPN transistor. Here the emitter current is large, but this IB, that is the base current, turns out to be very small current, and the IC turns out to be a large current. Okay, this is large, this is also large, but this IB is very small. Okay, and I is nothing but IB plus IC. Okay, here we have considered some electrons. Let us say this 1, 2, 3 and 4. What? They are crossing the emitter, isn't it? And they are crossing the emitter from N region to P region. Okay, and from this base, that is the P region, hole is moving towards the N region. Means very small amount of holes are moving towards N, but more number of electrons are moving from N to P, isn't it? That's why we can say the total sum of this charge carrier movement constitute the emitter current, and emitter current is large. Now, only a portion of this current is due to the movement of electron 1, 2, 3 and 4. These are the electrons injected by the emitter in the base. Now, the ratio of electron current to the total emitter current is known as emitter injection ratio, or the emitter efficiency, which is almost 0.995. Okay, now we have this small base, okay, which is a narrow one, also lightly doped. So most of the minority carriers, that is electron, traveling from emitter end of the base region, they move towards the collector region and do not recombine in this base, isn't it? See, 1, 2, then 4, they are directly moving towards the collector region and they are not recombining in this base, isn't it? So only a few electrons, suppose this 3 is moved from emitter and recombined in base. Okay, from where this it come from electron from this n, that is this electron and this hole, they get recombined over here. Okay, the ratio of number of electrons arriving at collector to the number of emitted electrons is known as base transportation factor, and that it is denoted by beta, and which is equal to again 0.995. Okay, so moment of holes, say from this collector, say this 8 number from collector region, and electron from this P, okay, base region, they constitute some current, and that current is called the leakage current. The motion of this electron from this 3 number electron moves, and 7 number hole, they constitute a part of current which is called IE, and this current is not equal to the leakage current. Actually, the number of electrons and holes crossing the emitter base junction is much more. This electron, from electron to base, number of electrons, motion and holes is more than the number of electrons and holes crossing the collector base junction. Means electron holes crossing in this junction is more, whereas the electron holes combination passing this junction is less. And the difference of these two current in the base region makes the base current, that is IB. This IC is less than IE. As earlier I told you, IE is equal to IC plus IB, and IB is very, very less. So ultimately this IC will be less than IE. There are two reasons for this. Firstly, IE consists of holes that do not contribute to IC, and the electrons injected into the base are successfully reaching the collector. So the ratio of the IC to IC, which is called ratio of IC to IE, is called alpha, and that comes out to be around 0.99 for this transistor. So this is all about the working of NPN transistor. Now let us see the PNP transistor. The PNP transistor, again this base, that is N, is sandwiched between the emitter and collector, where emitter is p-type conductor and collector is a p-type conductor. Here, as I have earlier said, that the arrow of the emitter is towards the base. Okay, so this is the simple difference between NPN and PNP. In NPN, NPN is there, but in PNP, emitter is P, base is N, and collector is P. And when we draw the symbol, it is very important to indicate this arrow towards the base. Okay, so this PNP transistor is the exact opposite to the NPN transistor device. In this type of transistor, construction of two diodes are reversed, as I have said, with respect to NPN transistor. This arrow defines the emitter terminal, and this is pointing inwards in the transistor symbol, that is towards the base. Similarly, all these polarities are reversed as compared to NPN. In PNP, this emitter is connected to negative and collector is connected to positive, but in PNP this emitter is connected to positive and collector is connected to negative. That is exactly reverse to the NPN. Or we can say the polarities are reversed, and that means this PNP transistor sink current as opposed to the NPN transistor which sources current. Then NPN transistor uses small output base current and a negative base voltage to the collector. This is connected to this IB base current, and it gives negative base voltage to control emitter collector current. The construction of NPN transistor is what we have seen now. This base current in this PNP transistor needs to be more negative than the emitter current. It is around approximately 0.7 volts for silicon and 0.3 volts for germanium. Base current or collector current are the same as we used in NPN transistor, and similar to the NPN transistor, IE is equal to IB plus IC. Okay, and IC is equal to beta times IB, where beta is the gain. So from this we can say the NPN transistor can replace PNP transistor in electronic circuit, and the only difference is the polarities of the voltages and the direction of flow of current. With this I stop here. Thank you.